to take a look at a new kind of function, which you might not have ever heard of before. It's called a parametric function. Here's the idea behind it. An example. If you throw an object off of a roof, the horizontal distance of your throw would be in this direction, and the vertical distance, or the height, aren't really dependent on each other. What they depend on is a third variable, time, the amount of time the ball or whatever it is you're throwing has been in the air. This is an example of what we call a parametric function. After any moment in time, so let's say after 1 second, the ball is right there. The ball will have a coordinate, x, y. But those two values don't depend on each other. They depend on how many seconds the ball has been in the air. So we'll call that x of 1 and y of 1. This is called a parametric function, a function where two different dependent variables are based on the same independent variable. For some reason, we call that independent variable a parameter. We call that independent variable a parameter. And I apologize, this should not say of a third function here. This should say of a third variable. Okay, let's take a look at an example, and it'll make a lot more sense. So here's a pretty simple example. We've got a parametric function, so two different variables, x and y, two different dependent variables, x and y, that both depend on t. Usually we think of a parametric as where the t is time. It doesn't have to be though. So if x of t, the x variable, is the sine of the amount of seconds, or sine of t, what that tells me is that the x value of this coordinate will just go forward and backwards and forward and backwards and forwards and backwards and forwards and backwards, because that's what sine does. It goes up to 1 and down to -1 over and over and over again. So this function, the coordinate in this function, will just go to the left and to the right and to the left and to the right and to the left and the right over and over and over again. At the same time, the y value is also a sine curve. So at the same time that the xy coordinate is going up, forward and backwards and forwards and backwards and forwards and backwards, it's also going up and down and up and down and up and down and up and down. It's just that it's going up and down faster than it's going side to side. So we've got a point. We'll start it when t is equal to 0. The sine of 0 is 0. The sine of 2 times 0 is still 0. So our point starts right here. And because the x value is a sine curve, our graph is going to start moving forward and also up at the same time. But it's going to move up faster than it goes to the side. So move up and to the side and then come back down. And it'll just keep going like that. But I'm getting ahead of myself. Let's look at one point at a time. So what we'll do is we'll just plug in different values for t. Because my x and y are both sine curves, I will use radian measures, pi over 3, pi over 6, things like that. So let's say after pi over 3 seconds, I'm only choosing these, I'll start with pi over 6. After pi over 6 seconds, and I'm only choosing this number because it's easy to plug in to that. So the x value is the sine of pi over 6, and the y value is the sine of 2 pi over 6, or pi over 3, which is root 3 over 2. So the y value, the x value is 1/2, and the y value is root 3 over 2. Root 3 is about 1.7, so root 3 over 2 is about 0.85. It's really a little bit more than that. So we've got a coordinate at 0.5, 0.85. Let's scale my y-axis the same way I scaled my x-axis. 0.5, 0.85 is about up here. So in the time that it took our t to go from 0 to pi over 6, our coordinate has moved up to here. We can look at another point, pi over 4. Again, I'm only picking these numbers because they're easy to plug in. I know that the sine of pi over 4 is root 2 over 2, and the sine of 2 pi over 4, or pi over 2, is 1. So I didn't draw this all that well. The next coordinate will be at root 2 over 2, which is about 0.7 or so, comma 1. So my next point will be up here. And now the x value is still moving forward. If I let a little bit more time go by, up to pi over 3 seconds, my x value has moved forward. And go over to pi over 2 a little bit more time, my x value has continued to move forward. So my x value is still going to the right, but while that's happening, the y value, you'll see, is going down because the sine of 2 pi over 3 is root 3 over 2. And the sine of 2 pi over 2 is 0. So what's happened is my next two coordinates are root 3 over 2 comma root 3 over 2, which will be about here. And then 1 comma 0. It's a pretty steep drop. So my graph went like this. As we go forward, if I start plugging in more values for t as t gets bigger and bigger, in other words, more time goes by, these values will get bigger. The x values will, the t value, as the t values get bigger, the x values will now start to get smaller because we've maxed out my sine. So my x values will start coming back down this way. And at the same time, my y values will be going negative because I've already got to the sine of 2 pi over 2, which is the sine of pi. From here, there's nowhere to go but negative. So what's going to happen is my graph will come down like this. And you might be able to guess, then the x values will go negative while the y values go positive. And then for a little bit of time, they'll both be negative. And the graph will look something like that. If you would like, you can certainly pause the video and plug in a handful more t values to see that this is true. I would try 3 pi over 4, or maybe I'll try 2 pi over 3, 3 pi over 4, pi, and just to see what happens. That will finish off the rest of this. And then if you want to, you can keep going past there. 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. If you want to pause the video and fill out the rest of these x, y values, you'll see the graph continue the way I sketched it a second ago. But what I also want to show you is how to do this on Desmos. So we'll take a look at this. This is very different from what you're used to. First off, you can simply type in a parametric function because it is x and y are the two equations. You can type them in as a coordinate. Sine of t, comma, sine of 2t. This was my x of t that I just graphed, and this is the y of t. So I'm going to graph it as x, comma, y. Notice how they automatically give me a t from 0 to 1. Well, I want to go as far as 2 pi. And you can see that's the graph that we showed. Another cool thing you can do is graph it a moving coordinate around here. If instead of using the variable t, which will then use every value for t between 0 and 2 pi, if you want to, you can use some other constant. Let's call it a for the moment. And then I can make a slider for a. Let me control this to make it also go from 0 to 2 pi. Make this point a little bit bigger. Oh, that's the wrong control, sorry. That's the one that controls how big it is. And now if I make this move around, you can see as, and I'll make this step here go up by, let's do pi over 12. So very small little steps here. And you'll see as this goes up, it goes around the curve just like the points that we showed. So you can see it going around just the way we described. Last thing you might want to do is make a table of values to show all of this, which you can certainly do. It won't graph this, but you can type in the table just the way we did before, and you can see the same, whatever y values you want to plug in, it'll plug in. This, we don't want these points to be graphed. But you're at least seeing the numbers that we had on our table before. Oh, sorry, that messed up my t sine of t. Oh, that's okay. And so now you're seeing the points pop up as I make them. And if we kept going, we would see the rest of the points pop up around.